Hello, everyone. Today, I'm excited to share with you a tool that we use to help us define and enforce context for AI assistants and agents. The extreme modularity of these systems means we have to think about this problem a little bit differently. It's about building nice, concise tooling that can then be dynamically synthesized into a complete agent that fits the user in the context they're in. Enforcing this narrow context isn't just about security, it's fundamental to the performance. The core of the tool is this concept of touch points, and that's where we're going to spend our time today. You'll see that I've created a basic one that we're going to go in and edit, but the way to think about these are where you define the context and tooling for your agent. So we're going to hop into assembly station here, which is characterizing an assembly station for a battery pack inside a factory. On the left, you can see the configuration, and on the right, there's this visualizer. You'll note the visualizer has a user role. We'll dive into that later. For now, let's start by setting up the characters. Characters are the traditional prompts for persona and procedure that are given as a system prompt to an LLM. And so we're going to go through here. We're going to give Alex to the default, and we're going to say for the operator, we'll do the same. And then for the technician role, which is more debugging, we're going to use Bex. Each of these is tuned slightly differently, and they have different sets of prompts. On the right, you'll see that it updated here, and it is now showing that Alex is for the default role. Now we're going to get into modules. These are the tools that give an AI agent or assistant a lot of its power. And so we're going to start with the agent section and we'll work our way through it. So to start here, we're going to add a couple here, the line maintainer, and we're going to add the other one, the visual inspector. Now you'll note as they come up, there's this concept of specific context. These are parameters that can be passed to narrow the scope to be specific to the instance we're talking about here. In this case, it would be the assembly station, which is where we're working. And we'll do that down here as well. There is a default value for each of these, so we don't have to modify every one of them. You'll note, even though we added them, they didn't appear over here. Neither of these agents is accessible to the default role. However, if we go to the operator role, you'll see that it is able to access the visual inspector and will be added as part of the system. Next, we're going to add a few MCP servers here real quick, just to flesh this out a little bit. So we're going to add our oscilloscope, which you'll note for the operator comes up there. And finally, we're going to add the board database. The board database has this board ID, which needs to be passed with every query. So in this case, we're going to actually define it for it and say it can only access the Olympus PVT. It doesn't matter whether my operator has more permissions than that. It is bound to be that narrow. And finally, we're going to add one final piece, which would be our spatial model. And again, this needs to be defined for exactly the system we're at, which is this assembly station. Okay, now you can see on the right here that we've added a few different things. And as we shift between roles, the tooling changes. So what we really need in order to get one of these to work is we need to assemble it. So I'm going to save this, and then we're going to do assemble. This assemble is typically done by your back end and querying the assemble endpoint, which is available as well. Right now, we're going to use the auth flow just to show the real capabilities here and how we do enforcement. I'm going to hit assemble and let it create it. So what it's doing is it's pulling all the relevant details necessary in order to be able to talk to each of these modules and also all the prompts associated with the character for the operator and bringing it together here. At the top, you can see the assembly details. This is the response that you would get from the assemble endpoint, and it can be used to run any of these AI SDKs. I've personally done it with LangChain and Vercel, and I also built my own custom one. It can work with any of them. It also works locally on-prem or in the cloud as long as each of the modules is reachable. There's really no difference. The enforcement part is probably a little bit more interesting. You'll note that with some of these, it replies with an auth code. You can think of this in the same way as an OAuth auth code that can be used to be passed to a token endpoint to get an access token, which is what you see at the bottom here. Each of these modules has received an auth code and has acquired an access token that is specific to it. That auth token encodes the user, the assembly number, meaning when this was called, and finally, the context as well. This can be used for your MCP gateway or elsewhere in order to enforce that your LLM or AI remains focused only on the resources you've given it. That's a quick overview of the Bifrost tool. If you're interested in using it, please reach out to me at info@memory.io, and I hope to hear from you.